Hello viewers, welcome back to another section of my YouTube channel tutorial. In this video, I'm going to take you through principle of mathematical induction. So the principle of mathematical induction is a principle used in algebra and is used to determine if a statement holds for all natural numbers. So if you have a statement P of n such that when you sum all the odd numbers to the nth odd numbers, it's always equal to maybe n squared on 5. This is a mathematical statement you have made. I can test for the first value, that is when n equals 1, because natural numbers start from 1 to infinity. I can test for 2, but how will I know if your statement is true for all natural numbers? And this is the reason why we apply the principle of mathematical induction to prove that a statement holds for all natural numbers. So this is the reason behind principle of mathematical induction. Principle of mathematical induction has some algorithm, a process we follow. The first step is what we call the base case or base step. So the base case or the base step. Now, under base case, what we do is we prove for the least value of n. So if you have such a statement that the sum of all these numbers, odd numbers, up to the nth odd number is equal to this, then we have to prove for the first the first value of n, that is when n is equal to 1. There are some statements with conditions. Some statements will say that 2 to the power n is always less than n plus 4, where n is greater than what? 4. Such a statement, remember that such a statement, you are having a condition that n should be what? Greater than 4. For that reason, your base case is not going to start from 1, but is going to start from what? 5. So you test for the least value of n. Now, let's see the second step for principle of mathematical induction. The second step is what we call the inductive hypothesis. Inductive hypothesis. When we say inductive hypothesis, the word hypothesis means a tentative guess. You are what? Guessing. So at this step of mathematical induction, what we do is we prove or we assume. So let me use the word assume because it's hypothesis. So we assume that the statement given is true for a particular natural number k, or for a particular natural number. So if you have your statement p of, let's say, n, a statement where all natural numbers which are, let's say, n to the power 3 is always greater than 2 plus n. So such a statement like this, at the inductive hypothesis, what we do is we are going to assume that this statement is true for a particular value of what? N, and we assume it to be k. So we assume that the statement is always true at k. So we change our statement into k whenever you reach the inductive hypothesis. So you are going to get p of k is equal to k cubed greater than 2 plus k, and we say that this is true. So the inductive hypothesis stage is where we assume a value for our statement to be true at all times, and that helps us to move further in our mathematical induction process. The final stage is the inductive step. So at this inductive step, this is where the main manipulations comes in. So at the inductive step, what we do is we prove that P of n plus 1 is true. What this means is that we first made a guess that P at k, or any assumed number which is a natural number, is always true. If that is true, then to know that our statement is true for all natural numbers, then it should be true for our n plus 1 stage. And in this sense, it's going to be our k plus 1 stage. So you can see that now we have said that our statement is true for k, yes. Now, if the statement becomes true for k plus 1, then our mathematical induction will prove it right that this statement is true for every natural number, because if an assumed natural number k, it worked, and k plus 1, that is the term after that k, is true, then it means that if we had used k to be 5, then 6 would be true. If we had used k to be 6, then 7 would be true. If we had used k to be 7, then 8 would be true, in that order, proving that the statement is basically true for all natural numbers. So this is the whole scenario of mathematical induction. Join me in the next video as I'm going to take you through the different types of mathematical induction problems and how we solve them. Thank you for watching this video. Don't forget to like, subscribe, and also share.